So there are like few types of cloud services. One is a storage service or the data lake that we usually refer. So in storage services, basically what happens is there is this different technologies. Like the three big giants are Azure, AWS, and GCP. So these three are the big giants that that have these features. Now, if I talk about the storage services, so Azure have ADLS Gen 2, where blob storage, where the files and everything comes, you can store the files, and like you can create a pipeline to store the files, and then you can read and write the data and everything. You can do it from that end. Now, second thing come as a database. So database is pillar for everything in data engineering. Whatever you need to store, wherever you need to store a data, it's a database. Now if I talk about a database, there are various databases that are available in market. Let's say you guys might have heard about the Oracle DB, then there is this SSMS, then there is this Postgres and XYZ. So now the third thing is VMs, virtual machines, where your servers are actually hosted. So this is a VM. And the fourth thing is ETL that I told, like the everything happens there. Extract, transform, load. Simple concept. You extract the data, read, keep into the staging layer, then move it to the transformation phase where you will apply the business logics and everything. Transformation happens, and then finally the data gets loaded in the data marts, or let's say whatever the business requirement is. Any questions still here? Like, feel free to ask, not a problem. I'm taking this as a no. Okay. Now, cloud computing also offers few service models as well. The first service model, like you might have heard of, is IaaS, infrastructure as a service. So basically, what happens is it is nothing but it is a virtualized computing resources that offers flexibility control without hardware ownership. Like you don't need to take the don't need to worry about the hardware and everything. You simply go on this portal.azure.com, like specifically for Azure, and these services are available, like the VMs that we talked about previously, and this there is this AWS service which is called EC2. All these are part of IaaS. Now the second
बेबी आपके बैक साइड पे है बेबी आपके साइड पे है क्या बेबी का शोर आ रहा था
not from my
सेकेंडली आपने कुछ स्क्रीन शेयर करने वाले थे स्क्रीन शेयर नहीं किया आपने
sure. Like I was giving an overview, then
sure.
then we have SaaS as a service. So basically, what happens in SaaS is it is a PaaS. It is a platform as a service. Again, when we talk about the platform as a service, so what happens is like there is a couple of platforms. Like in AWS, you will find as AWS Glue, and then if you work with Azure, you will find Azure Data Factory, where you will find the platform to develop and do your business logics transformations and everything. Then finally, it's the third service, that is SaaS. It is a fully managed software service. What a fully managed software service is, that you don't need to worry about the servers, nodes, anything. You don't need to worry about all those things. It is just that you need to code, you need to work. All those things are managed accordingly to the configuration. Like if you want, you can ask anything from here. Then okay, now now here it comes a like big data. There is a this big data word that is very fancy in the market when we talk about the cloud computing. Okay, let me share my screen.
So, Ritik, I have a question. So, can you give me an example for the platform as a service?
Yeah, sure. So platform as a service, basically, what platform as a service is what you need to do in simple words is like where you can code and do a transformation, like Azure Data Factory, right? Azure Data
Mhm.
Factory is a good example where you will open that tool, and in that tool you need to create your own pipelines from where you can inject data, and then you can extract, you can do a transformation as well, and then you can load it. Since you have this Power BI, then from somewhere or the other you might be taking the data, right? Maybe directly from the SQL server, or like maybe from the file.
Mhm.
Hmm. So uh, ADF is a good example for a platform as a service.
So, for the software as a service?
Software SaaS is like let's say we have this in AWS Lambda Redshift, where you can simply code. It is a completely serverless tool. You don't need to worry about any services. Like you don't need to configure any VMs, no node. You don't need to configure. You simply code it.
Mhm. Okay.
I'm sharing my screen. Yeah. Let me know once you're able to see. Are you guys able to see my screen?
Yes.
Okay. So when we talk about big data, right? So what happens is like big data is nothing but it is just a collection of huge amount of data that is exponentially growing with time. Like when we talk about the terabytes of data or the petabits of data, then big data comes into the picture where you need to load, transform, and do everything with the high amount of data. Again, these types, there are a few types of big data as well, right? The when basically there are three types. One is structured data, and then there is a semi-structured data, and then there is a unstructured data. So when I say about the structured data, basically in structured data, basically the data which you see in tables, and then the semi-structured data where you see in the files, like half of the data is okay, and then the half of the data is not very good. What I meant from this term is, let's say you have a Excel file, and the data in that, right? It is like the image. Let's say you have a image section and then XYZ sections. All the sections are not accordingly proper. And the third is an unstructured data. So basically, these three are the important types of big data that are being worked upon. Then there is this five V's of big data that we say. One is volume. Of course, volume by the name it suggests that the size of the data that we have. Second, the velocity, the speed at which the data is generated. Now these things you see, when you work with Azure Data Factory, right? Then you see, like, let's say if you need to copy a 1 GB of data, what happens is the speed at which it copies, it's quite low. It is not very fast. Like it will take around 2 hours, 3 hours to copy a GB of data. So here comes this Spark and everything, where the cluster management is there and everything like that, we deep down also, but just an overview. So there the data processing speed becomes very high. That's why big data is nowadays being preferred over the other uh, systems. Third is the variety, the type of data that you deal in. Let's say if the data is in JSON format and then CSV or whatnot, XYZ. Again, the fourth one is veracity. Basically, it is nothing but a data quality control check kind of control, that the data that you are receiving is actually of use or not, like the accuracy should be correct, and like the data you are receiving, it doesn't have the duplicates, and all the columns have the correct value, the number is not in the uh, let's say you have a customer ID and then the name, then name is not overlapping in the customer ID and everything. That is veracity. And then you finally the value. So what value is in, like the data should be of some use, otherwise it has no value. So wo- let's say you have worked on the Power BI, right? So there might be a structured data that you might be pulling and putting some sense to it, so that business decisions can be done accordingly. So these are the 5 V's of big data. Now another thing is, uh, okay, there is this one concept called distributed file system. So what happens, what the word suggests is the distributed file system. Basically the distributed file system means that the data that has been distributed into these small parts. Let's say in 1990s and 2000s, basically what happened is, like there were no proper infrastructure, nothing, but the amount of data and that we need was very high. So there was this one American guy who came into a picture, and he like he suggested, or he came up with a solution. Basically was to, what to do is to take a raw data. Let me open Paint. So let's say we have this data. It fills some colors in it. So
Is there some network issue and the voice is not coming properly?
no, like from my end, I don't think so. Like, am I not audible as such?
I was facing the issue, but the voice was not coming clear. That's why I was asking, is there any network issue? Is there?
No, not from my end. Like, not sure if same is happening with others.
Okay.
So basically, let's say we have this as a input file where our whole chunk of data is there. Now, what distributed system means is, it divides the data into smaller parts. So once we have a complete data, it divides the system into the smaller parts. it gives some data to this, it gives some data to this, it will give some data to this. So that's how this distributed system works. Now what happens is, when we have distributed the data for processing, we need to collect the data. Again we need we need to collect this data. So for collecting this data, we have came back to square one. Here again we have a same problem, that data again has been grouped up, and because of that, this there has been no like again the time would be more, and then there is a huge data. So it is next to impossible to do any kind of logic or transform the data. So there, after few years, there has been this Google file system. A new system came up, where what happened was, what Cutting said is that distribute the data into the systems. But what Google said is, instead of distributing the data, distribute the code. Let's say a code may be of like Python, SQL, anything. Basically, you code and you will get some chunks of data here. Again you code, you will get some chunks of data here. Again you code it, you will get some chunks of data here. So that ways it would be more feasible. So once this theory came in, like it is a backstory, like how HDFS actually came into the picture. So again, the original guy who gave this data distributed system technology kind of thing, what he did is he came up with a solution, HDFS. HDFS is nothing but Hadoop distributed file system. So what happens with the Hadoop distributed file system is, what he said is, two strategies he implemented. One was distribution based on storage of data, like the initially thing that he told, to part the data into the different nodes. There can be more nodes as well, not only three. I had taken an example. And second thing is distribute data by processing, that which is called as map reduce. Any questions still here?
No.
Okay. So now we can move to map reduce. Basically, what the actual concept of map reduce is, let's say again there is this input file data, where we have one gateway node, okay, where the complete data is available. Then this DFS comes into the picture, distributed file system, where again the data is being transferred into the three chunks. Let's say one block, second block, and third block. So once all these blocks are available, then what happens is, then this another part comes in, called as distributed processing. That means you need to do a code on the small part of data. You do a code again. You will do a code in this. You will do a code in the second system. You will do a same code in the third system. Now, when all the three codes you have given, then finally to this data, right? Again, what you will do is, you will create another block. In this individual data gets grouped up. Let's say initially you had a data of let's say three vehicles. One is a Tata, one is a Toyota, and another one would be a Maruti or anything. In the first, you have two Tatas and one Maruti. In second, you have few Tata, then Toyota and everything. And the third, you have some kind of combination. So what it did is, it according to block, according to a vehicle. Let's say if we had three Tatas in three uh, databases, so it has accumulated into the one. So we have, let's say, three Tata, three Toyota, and two Maruti or something, and then finally it came here. So this is called reduce. So this is an whole concept where this map face reduction comes into the picture. So this is about the map reduce. So when we talk about map reduce also, no, there is this one thing that also happens before putting the data finally. This shuffling thing happens. So the thing I told you, like the grouping of data, no, that is basically a shuffling of data. So what happens is when the data gets shuffled, right? There is a, like, the it is slow, but we can't ignore it. That's how this, there are certain steps that we can perform to improve, but later, of course, we can understand that. As of now, the high level architecture about the map phase shuffling, map phase reducing, this only. Any questions still here? Okay. Yes, no. So there are a few names of the tools and the programs which help in processing data. Like there is a Spark, Kafka, and whatnot. But this one is like high in demand, and mostly in industries and everything. No, this is used, the Spark one. We come to the other things. Then now there is this Hadoop picture kind of thing. So basically, this is a master slave kind of architecture where you can see this SDFS client. It interacts with the main node or the name node. This is the main node, and it has few slaves, which is data node. If you see below, these are the data nodes, 1, 2, 3, and whatnot. Like it depends upon completely the configuration about how much the project we need and what we need. So basically, what it does is, uh, if suppose if a user runs any query, fires any query, SDFS client, it interacts with the name node, and node, when name node gets to know, okay, this is firing a query to fetch some data. Now it gives that instructions to the data node 1, data node 2, data node 3, and 4. Now these are the 4 data nodes that keeps interacting with the name node. Like it is a kind of heartbeats which is being sent to the main name node. So like again, that is again uh, configured. Like let's say you have given a time of 10 minutes. Like in every 10 minutes, this data node will send a heartbeat to the name node, and name node will monitor that if any data node is down or up, XYZ. So accordingly, this happens. Now what happens in data node has a replication of a data. Let's say if you see this green, red, yellow, and orange, right? You see in couple of places. Even if you can see here it's green, here it's green. So it means there is a replication of data in the different nodes. Why it is needed is, let's say we have this data node. Sometimes what might happen is it didn't reach to the name node. So once if it didn't reach to the name node or the main node, it will understand, okay, this data node has been failed. Anyone saying something? Hello.
No.
Okay. So what happens is this name node will be uh, checking the heartbeats that is being sent from the data node to the name node. So if let's say you have configured it as like 10 minutes, okay, so in 10 minutes if you didn't get the heartbeat, then it will think as this currently data node is down. So now we have started with 1, 2, 3, 4 data nodes. Now if one data node get got down, that means there has been a under replication. This term is called as under replication. That we started with the four, like 4 or 5 nodes, and one node got down. So what name node automatically does is it will take a particular, it will create another data node with the same amount of data replication. So it starts running. So you don't need to worry if this got failed or anything. That's okay. There would be another data node that would be uh, will be up and keep on running it. So this doesn't impact your performance of queries in between. Now there is another scenario. Let's say the node that got dead, right? It came up after 20-30 minutes. This node came up. Now what happened is the name node understands, okay, 1, 2, 3. Previously we have it like 5. The now we have 6 because another node comes into the picture, and already 5 are running. So that is called as over replication. So what over replication is? Over replication is the amount of nodes that we need to perform a task, we have more than that. So to balance it, what happens is name node automatically cancels one node, the existing node, it cancels it, and the system uh, is again start up and running. So this is a high level about the architecture of the Hadoop. So and when we say okay. Another thing would be here is, let's say name node itself got data. Then what do we have? This is our main node which interacts with these node. Now name node, due to some reason, it got failed. So to balance it, we have a secondary name node. So in name node internally, what happens is there is this checkpoint time that is again configured according to the business. Let's say at the name node, the checkpoint time is of around 30 minutes. So every 30 minutes, the data keeps on sending it to the secondary name node. So this start like this up and running. It stores the secondary this it stores the data from the name node, and whenever this gets unavailable, this becomes the primary node. So because of this, your performance doesn't get impacted. But of course, like, there is this data lineage and everything that happens in between. So that is again tackled with different architectures as well. So this is about the high level about the architecture, what data node does. Like if you have any questions, you can ask it, like the data node or the name node or the anything till here.
So Ritik, so this apart from this data node and then the name node, this Hadoop distributed file system is available separately for the Windows and Linux, right?
Hmm.
So may I know what are is it right or no?
No, basically Hadoop, like distribute that is again, and this cloud data as in service, right? Like Hadoop is a distributed file system that is available at your cloud level. So there is not exactly whether it is Windows or Linux. You don't need to take care about that.
Okay. Okay, so may I know then the Hadoop systems have this FAT32 NTFS? May I know what are those?
Sorry, could you please come again?
So this FAT32 NTFS, may I know what are those?
MT 32. I think I can get back to you with that question. Exactly, I
Okay,
don't understand. Yeah.
no problem, no problem. So you said the name nodes, right? So may I know how many nodes it supports? Is there anything kind of
There
anything
is
specific?
there is no. There is no any specific nodes. Again, it is dependent upon the logic and the requirements on your business. Like you can like you can configure nodes according to your business requirement. There can be two nodes also that is handling it. There can be four nodes also, but the
Okay.
main node would be one. The parent node would be one that would be communicating with the different data nodes according to the requirements.
So there is no like this many kinds of nodes can support this many machines kind. There is nothing like that, right?
No.
Okay. Okay, you can proceed.
So again, like this is an internal architecture of the same thing. Like uh, what we are doing is like this SDFS client thing is there. Then there's a name node. There is this two thing that I was telling about the heartbeat and all, right? So this is the responsibility of a job tracker to interact with different blocks of nodes. Let's say that there is this task tracker, and this task tracker this keeps on doing the required task, and this job tracker keeps on tracking the different tasks that is available. So, and these data nodes can be of n number according to the requirement. Okay. Now, so basically, there are now the few drawbacks of this also. Let's say if name node fails, then the current FS image is lost. So recent transactions are lost. So what it means is if if this name node, right, name node is a proper a system where this captures in two forms. One is FS image and another is edit logs. So what happens is when the name node gets fails, right, so this FS image doesn't capture the amount, like the transactions which are done after the failure. So that gets missed. So this is what FS image it is. And then another thing is name node size increase. If the data in the name node increases, scalability becomes an issue. So this is another drawback. If if let's say if we have only just one node that is working in here. Now if the data got increased, right, then what happens is this system becomes slow, and sometimes you may see an intermittent issue in a real project that data is not getting copied up, or maybe it got stuck, it doesn't move it at all. Like the job that was taking around, let's say, 20 to 30 minutes to complete a data, that has been stuck completely. So this is where this comes into it. Oh, okay. Again, like we have this different kinds of architecture that we have. Again, the we may deep down into the details maybe later. So this is one thing. Then we have this storage. These things not required actually.
Okay, may I know what is this map reduce?
Yeah, so initially, like the map reduce, I told you, right? Basically, what happens in map reduce is initially, let's say in 1990s or something around that, there was only one thing that was there, that a distributed file system. There was nothing uh, about like the this guy, the dog coupling. It came up with a picture that only the data can be distributed in three parts, like three or four, like small chunks of data. But but Google file system solved that problem, and it said, instead of bringing up the data, bring up the code. And that will, if you run an individual code, that will give a small amount of small chunks of data. So when Kaling saw that, so what happened is he came up with the two solutions, that we can do a distributed data as well. Only data is not sufficient if we are unable to process. So MapReduce is a data processing process where what happens is, instead of bringing the data, it brings the code, and code will run with the small chunks of data. So once a small chunk of data is came in, on top of that, code has been done. So once the code is done, uh, it grouped, like basically it shuffled the data. Let's say you have a data of four things or three things, like you can take any car company, and you have three data, and you need to group the data into one specific model. So shuffling, it does it, and finally it writes into the grouped form. So that is a complete thing of map phase reduction.
Mm-hmm. So, is there any example for map reduce?
Uh, like map reduce is basically a technique, like simply,
Mm-hmm.
like there is no any system kind of thing. It is a technique. Like you see my
Okay.
page.
So, so I wanted to make sure. So, shuffling the data means like XML, no, 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 kind of what we can say Excel file, and then
No, no,
is
no,
is it kind of shuffling those kind of different
no,
data?
no. XML files and those files, you don't deal with file in here. It is
Okay.
completely dealt in the database, or the notebooks, or the Spark notebooks, where you are actually dealing with the structured data. So when I said that code should be there, right? Let's say if we are coding, let's say you have written select star from XYZ. Okay, it will give some amount of data, right? So
Mm-hmm.
what happens is, uh, uh, okay, uh,
You
let's
just
say,
tell me what kind of
no,
data it will
structured data,
combine.
structured data. It is only a structured data that gets shuffled. You don't need to work with files and everything. It
Oh,
is a
same structure data means it should be in some form, right? If it is a structured data means it should be in any kinds of form. So I'm just asking the example. So
no structured data. Basically, what I'm trying to tell you is, like in database, you have this data in a tabular format itself, right? So
mm-hmm.
you can take any data, you have done a code accordingly, that will give you some data that gets shuffled in individual blocks. Let's say there are one block, two block, three block. In individual block, that data will be shuffled. There is no file XML involved. It's
Okay.
completely a notebook or a database, depending upon what you are working on.
Okay.
Yep. Anything else?
No, from my side.
So these, yeah. So I guess till here we can do it till today. If anyone have it, please ask.
So I have one more question. So apart from this, what you have shown today, so how we are thinking to take this class? So I mean, what is the plans of taking the class? I mean, like you have kind of um uh, how you have kind of plans, right, to proceed like index.
Correct. So, okay, this is second. Okay, here we are. Let me stop. Yeah. So, for that, I wanted to understand. Like, see, if you are looking for a complete data engineering role, the roadmap that I usually follow is learning the SQL. Then you go to the Azure Data Factory, you learn Azure Synapse, then come to the Spark concepts bec- because like the backbone or the root is SQL. If you know SQL, then it's good. Then we can move it to ADF, and like if you know again ADF also, then we can move it to Spark. But jumping directly into the Spark and those things, that would be a problem according to me, although I don't mind it, but that would be a problem because you need to know the backstories as well, like let's say what SQL does it, how the data gets transformed. Like, you do you guys have knowledge on SQL and everything?
So for me, the SQL part is haven't taken. I know very basic codings in SQL. So as Power BI developer, I worked in SQL too, but not like advanced coding and all. I don't have any experience with that. So
What I'm trying to ask is like you know about the window functions and then the group by and then those,
yeah, those basics and those I knew. But still, the sequel is not completed. But I'm okay with if you're starting with area,
yeah.
starting with and proceeding from there is fine for me. And later I can take it. That's fine for me.
Yeah, so that's what. See, if you are comfortable with SQL, then we are good to go with the Azure Data Factory because again in the Azure Data Factory, that is a no code. That is not no code. There would be a code. So you need to write SQL. That's why I'm asking. If you are okay with, then we can skip the SQL and then we can directly come to the ADF.
Right.
And at the end, we'll go to the Spark.
So you're going to take area and then synapses in area. You're going to take synapses and
Yeah,
then
basically, see, if you understood Azure Data Factory, no, then it is same replicator. Synapse is like 95% same as ADF. There is a very small change, nothing much. Like you will see the infrastructure, like the layouts and everything completely same. So
yeah.
if you have learned ADF, then you are good with the Synapse as well, and then we can move on to this part. This is what I have taught. to go in this frame.
Mm-hmm. Okay.
Anything else?
No, from my side.
Harshit, anything from you? Reena, Vineet, anything? I guess we are good to close it then.
Okay, thank you.
Okay, thank you.